Welcome to our video about the incredible discovery of a gemstone on Mars by NASA's rover. This discovery has sent shockwaves through the scientific community and has many people wondering what it could mean for the future of space exploration. A research team using new methods to analyze data from NASA's Curiosity, a rover that has been operating on Mars since 2012, was able to independently verify that the fracture halo contains opal, which is rare on Earth, a gemstone formed by the transformation of silicon dioxide by water. The study found that the vast subsurface fracture network may have provided conditions that were potentially more habitable than on the surface. In 2012, NASA sent the Curiosity rover to Mars to explore Gale Crater, a large impact basin with a massive, layered mountain in the middle. As Curiosity traversed along the surface of Mars, researchers discovered lighter toned rocks around fractures that cross parts of the Martian landscape, sometimes far into the horizon of rover imagery extends up to recent work suggests that these extensive halo networks may have served as one of the last, if not the last, water-rich environments in Gale Crater's modern era. This water-rich environment in the subsurface also provides more habitable conditions when conditions on the surface are much harsher. As part of a new study published in Journal of Geophysical Research, Planet, led by former Arizona State University New Space postdoctoral fellow Travis Gabriel, now a research physicist for the U.S. government, examined archival data from several instruments and showed considerable anomalies near light-toned rocks previously in traverse. Coincidentally, the Curiosity rover had driven right on one of these fractured halos several years earlier, long before Gabriel and ASU graduate student and co-author Sean Zarnecki joined the rover team. Looking at older images, he saw a vast expanse of fracture halo extending far and wide. By applying new methods to analyze the instrument data, the research team found something interesting. These halos not only looked like halos found in completely different rock units much later in the mission, but were similar in their composition, entirely silica and water. Our new analysis of the archival data showed striking similarities between all the fracture halos observed much later in the mission, Gabriel said. Given that these fracture networks were so extensive and possibly filled with opal was incredible. Observing drill cores taken at the Buckskin and Greenhorn drill sites several years into the mission, scientists confirmed that these light-bearing rocks were very unique compared to anything the team had seen before. In addition to looking back through archival data, Gabriel and his team looked for opportunities to restudy these light-colored rocks. Once they arrived at the Lubanga drill site, a bright-toned fracture halo, Gabriel led a dedicated measurement campaign using the rover's instruments, confirming the opal-rich composition. The discovery of opal is notable because it can form in scenarios where silica is in solution with water, a process similar to dissolving sugar or salt in water. If there is too much salt, or conditions change, it tends to settle at the bottom. On Earth, silica precipitates out of solution in places such as lakes and the ocean floor and can form in hot springs and geysers, somewhat similar to the atmosphere in Yellowstone National Park. Since scientists expect this opal in Gale Crater to have formed in the modern Martian age, these subsurface networks of fractures could have been far more habitable than the harsher modern conditions on the surface. Given the extensive fracture network discovered in Gale Crater, it is reasonable to expect that these potentially habitable subsurface conditions extend to many other areas of Gale Crater and perhaps to other regions of Mars, Gabriel said. These environments must have formed long after the ancient lakes in Gale Crater dried up. The importance of finding opal on Mars would be beneficial to future astronauts, and exploration efforts could take advantage of these extensive water resources. Opal itself is composed primarily of two components, silica and water, with water content ranging from 3 to 21% by weight, along with minor amounts of impurities such as iron. This means that if you grind and heat it, opal releases its water. In a previous study, Gabriel and other Curiosity rover scientists demonstrated this exact process. Combined with growing evidence from satellite data showing the presence of opal elsewhere on Mars, These flexible materials could be a great resource for future exploration activities elsewhere on Mars. Credits: the material, information provided by Arizona State University. Thanks for watching. Kindly share and subscribe Space View channel.